Assalamualaikum and good day to everyone. So we are from S104K and we are going to present basic chromatography on application in drug testing. So this is our group members consists of 4 person, which is me, Muhammad Amar, Sheikh Muhammad Amar and Adam Luqman and Hakim.
For this slide, I will give a brief introduction to drug testing. Drug testing is a scientific method used to detect the presence of legal or illegal substance in the body. It widely used in workplace, sport, healthcare, and law enforcement to ensure safety and fairness. Common testing method involves urine, blood, saliva, or hair, each offering different detection period and accuracy level. Beyond enforcement, drug testing also helps with early detection and support for those struggling with sustained use, offering a path toward recovery. In short, drug testing promotes safety, accountability, and well-being in society. Okay, in this section, we will discuss the theory behind drug testing. Chromatography is a key technique used in this process to separate compounds based on their chemical properties, such as polarity or molecule size. In drug testing, gas chromatography (GC) or liquid chromatography (LC) is often paired with mass spectrometry (MS), known as GCMS or LCMS. This combination provides high accuracy in identifying and quantifying chemical substance. This method ensures a high degree of precision in identifying and measuring drug in biological sample, which is crucial for ensuring the accuracy of drug test result.
Yes, Assalamualaikum and good day to everyone. So today I'll be talking about the basic principle of chromatography. So there is 4 basic of it. The first one is stationary phase. So it may exist in a solid or liquid form. It is where the sample component absorbed and separated. And then we got the mobile phase. It also can be in liquid or gas form that move over the stationary phase, carrying the component of the mixture with it, which is the sample. And then we got the retention time. It is time taken for a particular compound to travel through stationary phase to the detector. And then the separation mechanism, the separation of compound based on differential partitioning between the mobile and stationary phase. Okay, now so this video will show you these 4 basic property that I told in previous slide. So the first one is different affinity. Different affinity in paper chromatography, and the black ink separates into different colors because each dye has different attraction to paper and the water. Then we got the stationary and mobile phases for the paper chromatography, which is the paper inside the glass, and mobile phase, some liquid under the glass of this video. And then we got third basic property, which is absorption or partition. So absorption chromatography, it's like TLC, which is thin layer chromatography. And then we got the partition chromatography, which is paper chromatography. And then lastly, we got the RF value or the retention time.
Okay, I will explain to you about gas chromatography mass spectrometry, GCMS. Okay, gas chromatography GC is a technique used to separate volatile and semi-volatile chemicals such as pharmaceuticals. The process works by evaporating the sample, then separating its component based on how strongly they interact with a stationary phase inside the column. Once separate, the components are identified using detector like flame ionization detector FID, mass spectrometry MS, electron capture detector ECD, GC is especially effective at detecting low molecular weight substance like cocaine and amphetamine. Okay, next is methodology. First, sample preparation. We started by collecting 10 ml of urine from the subject. The sample was centrifuged at 3000 rpm for 10 minutes to remove any particle. Then we add internal standard solution and acetone nitride to the sample, mix it and centrifuge again. The organic layer was transferred to a clean vial and evaporate under nitrogen anti-dry. Finally, the dried sample was made with derivatizing agent and heat at 70 Celsius for 30 minutes to prepare it for analysis. Second, sample introduction. 1 microliter of the derivatized sample was then inject into the GCMS instrument using a auto sampler. Third, separation. For separation, we use a capillary column with the following temperature program. Start at 70 Celsius for 1 minute. RAM 1, increase to 150 Celsius at 20 Celsius per minute. Hold for 2 minutes. For RAM 2, increase to 250 Celsius at 10 Celsius per minute. Hold for 5 minutes. Helium gas was used as the carrier at 1 ml per minute flow rate. 4. Detection. Detection was performed using instruments like mass spectrometry (MS) and UV VIS detector. We use electron impact (EI) mode with a mass to charge (ampersec) range of 50 to 550. For more accurate detection of specific chemical, selected ion monitoring (SIM) mode was used. 5. Analysis. We identified chemical peak based on retention time and mass spectra. Each drug and its metabolites have unique retention time and spectra. Using the calibration curve, we determine the concentration of each drug in the sample. 6. Lastly, confirmation and validation. To ensure the method is accurate, precise and specific, we use quality control sample with known drug concentration.
For my part, I will explain some real example of how chromatography is used in drug testing. First, in the world of sport, chromatography is used for doping tests. Athlete urine or blood sample are tested using techniques like HPLC or GCMS. These tests can detect banned substances such as steroid or stimulant. This helps keep sport fair and clean. Second, in crime investigation, chromatography is used by forensic scientists. They test samples like blood, urine, or even hair to find out if a person took drugs. This information is very useful in solving criminal cases. Third, chromatography is also used in workplace drug testing. Companies, especially those involving safety like transport or construction, test their workers to make sure they are not using illegal drugs. This helps protect everyone and prevent accidents. So, as you can see, chromatography is not just a lab technique. It plays a big role in real life, especially in safety, law, and sports. To conclude, chromatography is a reliable and accurate method used in drug testing. It allows scientists to separate and identify different substances in complex samples like urine, blood, or hair. Through techniques such as gas chromatography, mass spectrometry, or GCMS, even very small amount of drug and their metabolites can be detected. This makes chromatography is powerful tool, especially in situations that require high sensitivity like anti-doping tests, forensic investigation, and workplace drug screening. Overall, chromatography is not just a lab procedure. It plays an important role in protecting public safety, supporting law enforcement, and ensuring fairness in areas such as sport and employment. Thank you.